All right, I think I will go ahead and get started so we can actually get into the materials and have Sue speak. My name is Sarah Neville Morgan, and I'm a Deputy Director with First Five California. So I'm not sure if you all know about First Five California or the First Fives, but we are funded through tobacco tax. And as a state agency, we actually have something a little bit interesting in that we have dedicated funding for communications. And in that communications, and all of our funding is directed at children 0 to 5, so those early learning years, we have something called Talk, Read, Sing. I don't know how many people out there have heard the Talk, Read, Sing, seen an ad. It's like been, so we do things in our office where we're like, Talk, Read, Sing, play. Talk, Read, Sing, count. So Kristen's always our count one because she's our early math team lead. But as you all know, math and learning doesn't happen in isolation. It happens through interactions, through those relationships, and those early learning educators, those parents and families working with their children, actively engaged, reciprocal communication is where everything happens. So as you think through math and the wonderful activities and presentation we just had, I thought, what a window into children's minds. Doing those sorts of activities lets you know where the children that you're working with are, where they need to be scaffolded and supported, what sort of activities you can keep bringing into the programs, but it really was like you get to see where they are developmentally through those activities. What a neat thing. Unfortunately, we also saw where I was developmentally as we sat with our small group, but all good stuff. So some of our connections to early learning math happen I think every day through all of our pieces, but our Talk, Read, Sing is one thing that we will keep saying Talk, Read, Sing, count as we go through it. I am really happy to bring up Sue Dolphin, who is ready to go, I think, with her materials, and hopefully the videos will all work. That's what we're hoping. She is with Math Perspectives Teacher Developmental Center, and we'll be talking about understanding children's thinking through number talks. She's an education specialist for Math Perspectives, working across the country with teachers of grades K through 5 mathematics. Any TK in there? Oh, great. So TK as well. During her teaching career, she taught kindergarten through 8th grade. She's been a math coach, a literacy coach, and a project facilitator for a National Science Foundation grant in Clark County School District. She currently works as a math teacher for Southern Nevada Regional Professional Development Program and is also co-authoring a book, somehow in your spare time, with Kathy Richardson on number talks, expected to be released later this year. So we welcome you, and there you go.
Thank you. I have to get used to the microphone. As she said, I taught kindergarten through 8th grade, and listening to the previous two speakers, Patricia and Dr. Frank, and hearing them say that our children come to us with all this natural knowledge about mathematics. And I had the same experience when I went to middle school, and my 6th graders walked in the door and they were counting everything on their fingers for 8 plus 3. I was like, my 1st graders would have at least counted on. So my question, as yours was, what happens between our primary grades and our middle school grades? The other thing I learned is people think that you should get paid more when you teach middle school because you're doing the big math. And I say we're doing the big math. Everything we do in our primary grades affects everything that comes from there on out. So you guys are doing the big math with our kids. So number talks, I'll see I have to get the microphone and the clicker going at the same time. So number talks is a routine that we can do in our classroom that help children develop computational fluency that engages them in mathematical thinking that they bring to the table, not that we have in our minds. And it's meaningful to them. And the goal ultimately is to help them be good at addition, subtraction, multiplication, and division. So Number Talks is a short daily routine, 5 to 15 minutes. If I'm in pre-K or kindergarten, 5 minutes is about all they can sit there for. and we want to use that 5 minutes in the best possible way so that we're not wasting any time. We choose intentionally sequenced problems that the students are going to help make connections, build relationships between numbers, and traditionally kids have, I know I did when I was growing up, that everything was an isolated fact, and I had to learn all those facts. And if we can help kids know that all those facts are related to each other, if I know this, then I also know this and this and this. And Number Talks is a tool to help kids be able to do that. There are ongoing conversations about mathematics that give them the opportunity to develop mathematical competence. So, we're going to do a little math. And whether you're in the room here or remotely, please put your pencil and paper away because we're going to try to do it in our heads. Oh, Lord. All right. So when you know the answer to the problem posed, if you would just put a thumb in front of your chest to show that you have figured it out. And then when I see that everybody's had a chance to think, I'll ask you if you're willing to share. All right, here we go. All right. Before I ask people to share, go ahead and tell your neighbor how you figured it out. I cheated, I heard that. All right, if I could have your attention back up here. Two things. One, I want to know, raise your hand if you and your partner did it the exact same way. There we go. One group. Raise your hand if you understood the strategy that your partner shared. Raise your hand if you think you would try the strategy that your partner shared. Okay. All right, so second thing is I'd like to hear a whole group, some of the strategies that you shared. And the thing that I want the rest of you to do is on a scratch piece of paper or on the back of a handout, try to write the steps, the mathematical steps that the person is sharing as if you were scribing it for a child sharing. Anybody willing to share? Oh, okay. Oh, you have a microphone.
I took 2 away from 46 to make 100, so it was 144.
So I hear what?
Yeah, I took 2 away from 46 and added it to 98 to make 100, so 144.
Okay. Who wrote that down? How would we write that?
It would be 46 minus 2 plus 98.
46 minus 2. So then I need a new line. 98 plus 2 equals 100. And then I need a new line. 100 plus 44.
Could you add 2 to the 98 and subtract 2 from the 46? Draw that line, and then you'd have 100 plus 44 and do it that way?
Could you say it one more time?
Sure. You would, under the 98, you would put the -2, and then under the 40, I'm sorry, plus 2, and then under the 46, you'd have the -2, draw that line, and then add down that, or, you know, so this would be 100 plus 44.
Yeah, so you could add some parentheses. So the main thing we want to make sure that we're doing is recording it mathematically correctly. So sometimes we get a running sentence going, and we want to write it as if it's one long number sentence. And so if I were to say 46 minus 2 plus 98 plus 44, those equations don't all equal each other. So we want to model that mathematically correct writing. Anybody else like to share their strategy?
So when I looked at it, I went, well, I know 8 plus 6 is 14, and 14 is a 10. If I add that 10 to the 90, I have 100, and then that gives me the 40 that there, so that's 140 plus my 4, so it was 144.
144, okay. Anybody else like to share?
You might be creating yourself a little more work, but you can round up. You can make 98, 100, 46, 50, and then subtract the 6 to get 144.
So kids do that, and then sometimes they get stuck. The biggest thing they have to remember is, did I add too many or take too many away? And that will help them know if they should add some back or take more away. So it's keeping track of that. Anybody else? All right. You guys ready? Next problem. What's that? Share with your neighbor. How are you?
I'm good. Now we transfer the skill from the last one to this one.
Right.
So when you try on another one.
All right. Oh, wow. The only time I like a microphone is when I'm doing lunch duty and I get to sing to the kids. I won't sing to you, I promise. All right. Anybody willing to share their strategy? Before we do, is there anything you want to, anybody change their strategy from the first time? Try something new? Okay. Who would be willing to share?
Okay, I confess in the first one I actually carried over the 1 and did it old school. So when I learned that faster way about just adding 2 to the 98, then I was able to transfer that to this one and get to the answer quicker. So I'm kind of feeling like a star student now.
You did that after just one practice.
I was going to say the same thing. I did it exactly the same way that I did last time, and immediately thought of the carrying the 2, and came up with the same answer.
Thank you. Anybody else? All right. So the reason I have this problem following the first one, why do you think? Transfer. Okay. If kids figure out something while somebody else is sharing, we want to give them the opportunity to practice it. Because I figured it out today, and tomorrow I'm going to forget. Not always, but we want to give them a chance to practice. At the same time, we don't want to make it too predictable. We don't want number talks to be predictable, that they know what your next question is going to be. So obviously I also flipped the order of it so that they'd have to find that 98 somewhere else. You guys ready for one more? You got this. Thumbs up when you have a response. No. Okay, one more time, I'd like you to try to write down the strategy that somebody shares, just so we practice that mathematical writing. Who's willing to share? With kids, it's who wants to share. With adults, it's who's willing. It just is. Anybody? Thank you.
So it's kind of the same again. So you take away, so 298 plus 2, I did it in parentheses, and then plus 34 minus 2.
Okay.
And then it equals 332.
332.
Yeah. But it looks, I feel like it looks so much more complicated than when you do it in your head so much faster.
When you write it down.
Yeah.
Yes. And I'm glad you brought that up, because I think a lot of people think that this math is a lot harder and it takes longer, but what happens is it happens really fast here.
Yeah.
And then when I try to write it down, it takes a little longer.
Yeah. And that's what I think confused me at first when I was saying it the first time. It seemed easier just to say it out like
just
that,
to say
but then
it.
you do have to put the parentheses so that
What comes
as an
first.
equation. Yeah, exactly. Yeah.
Thank you for sharing. All right, and the reason I selected this problem next is just because one of the big ideas for kids is the structure of our number system. And if I can learn to make a 10 by adding 2, I can learn to make 100 by adding 2, or the next 100 by adding 2. I could change that problem to 2,298. Maybe I could even throw a 134 in there and see how they do. So we're working on the structure of the number system. What else do we have to know in order to do that? Place value. You have to know how to break those numbers apart to see which piece they can use in a different place. Okay? Building that 10, yes. Starting in our earliest ages, how many more do I need to make 10? And if they know those parts, that's why we do the big math. This is the big math, because if we don't know that, then nothing else comes. Anybody else? So this is kind of the number talk procedure. The first thing, the teacher presents a problem and allows the students think time. Number Talks has taught me how to have think time everywhere. You're forced to by the action of the thumb. And the reason that we do that is so that the kids around us can continue thinking. When somebody's waving their hand, oh, they got that. So we want everybody to be responsible for thinking in the classroom, and the thinking thumb helps with that. Students figure out the answer and use the thumbs up signal. Students share their answers and defend their thinking. If you're writing their answers on the board, or if there's a lot of different answers, what does that tell you about the problem that you selected? I'm sorry? It may not be the best problem. If I have 15 different answers, I'm kind of targeting the wrong spot. How about if I only have one answer? Probably too easy. If they're always getting it right, and I tell my students that as well, if you have it right every time, then I'm not giving you problems that are challenging you and pushing you to think beyond. So that is your first indication of how to choose your problems. Before we finish with the kids, we want the class to agree on the answer to a problem. It doesn't always have to take place immediately following that number talk. Might want to come back to it, but we don't want to leave the wrong answers for people to go, I wonder which one it was. So, and then we just repeat those steps for additional problems. I have this. Right, so the National Council of Teachers of Mathematics says that computational fluency refers to having efficient and accurate methods for computing. That's our goal of number talks, to develop those strategies. We want them to be efficient and accurate. They exhibit computational fluency when they demonstrate flexibility in the computational methods they choose. So there isn't a goal for every kid to try every strategy on every problem. Because if they are, then some of those strategies aren't going to be efficient for that particular problem. And I've seen where sometimes we do 1 strategy, 2 strategies, 3 strategies, 4 strategies. By the time they get to the 4th strategy, that's not going to be a very efficient strategy. Really it is, I have a strategy, and maybe I have one to prove it. But if I'm asking them to keep coming up with another strategy, and they say, oh, well, I could count on, well, is counting on 46 more going to be efficient? It's not. So it isn't about finding more and more strategies. It's about finding the most efficient for the particular problem that they're solving, as opposed to every strategy for every problem. The students should be able to understand and explain those methods and produce answers efficiently. So what are the essential elements of a number talk? Safe environment. What does that look like? Talk to your neighbors about a safe environment in your classroom. All right, what are some of those things that create a safe environment for our children? The relationship between the teacher and the child. Your attitude towards what you're discussing. In math, it's that disposition, that productive disposition. That we love math, they love math. Yes. It's okay not to have the right answer.
Encouragement. Oh, I have a loud voice. I'm okay. Just encouragement. So, because we help build their self-esteem. So, a lot of children say they can't do something, but we're there to, scaffold them and help them get to that next level.
Encourage them.
Yeah.
And one of the ways that we can do that is they don't always have to solve the whole problem. How far did you get? Sometimes it's they got the first part and then they got stuck, but let's let them share how far they got.
I teach TK, and it's important for them to understand that not everybody has to know everything. Everybody knows something, and through collaboration, then we can work together to accomplish more.
And then we learn from each other.
The thinking and the answers come from them. They don't come from the teacher. And a lot of teachers I work with have a hard time with that, especially when wrong answers are thrown out there. But that you're not the one who holds the answers, right? It's all about the children figuring out themselves.
And what they're figuring out.
Yeah.
Anybody else?
Well, I think like the protocol that you established at the very beginning, where there's not this kid waving their hand like I've got the answer, so that doesn't shut down kids' thinking, and the whole idea that what's valued is the thinking and the process, and bringing that so the kids feel like even if I'm thinking about it a different way than the teacher or my friend, it's still a good way, or it's still a viable way to think about this problem.
Absolutely. Anybody else? I know when I walked out of college, I walked away with a sheet that said 101 ways to praise your children. Fantastic, fabulous, amazing. And one of the things that I've learned, and it's taken me a long time to kind of adjust, because as educators, we're nurturers. We want to make them always feel good. But feeling good isn't me saying, wow, that was a great strategy. Because if I say it to you and then I don't say it to you and I don't say it to you, all of a sudden, well, was mine great? So it really is kind of a neutral situation. We're not praising or criticizing. And it's hard. It's really hard because we want to say, that was amazing sometimes. But then if I don't say it to my other kids, then they're wondering, well, was mine amazing? So the best praise we can give our kids is our ear, by listening, genuinely listening to what they're having to say and making sense of what they're trying to say, and sometimes clarifying for them some language that they might be having trouble with. But all of these things that you talked about with a safe environment, and I forget who said it, it's them coming to the table with the math they know, and they're not trying to figure out what the teacher wants. As soon as I'm saying, that was great, then they're like, okay, maybe that's the way she wants me to do it, instead of, I can do it the way I want, which I think that was you talking about that. That's really critical, whether we're assessing or doing number talks for pretty much anything. In our number talks, we want to have problems of various levels of difficulty that can be solved in a variety of ways, and we're going to look at some kids in a few minutes. But we have kids in our classroom that are at a wide variety of levels, and we want them all engaged in that number talk for that 5 to 15 minutes. So in order for that to happen, we need to choose problems that my lowest kids can access and my highest kids can access. In addition to that, concrete and representational models, that really brings in some of our kids that might not get it if we're only using numbers. But if they have a concrete model to look at, then all of a sudden they have access to a problem that they might not have had access to. If I'm one of the higher kids, maybe I don't need the model, but then I can turn around and prove my strategy with the model so that the other kids in the class can kind of follow along. So we're helping them to see another strategy, perhaps. That interaction between the teacher and the kids, between the kids and the kids, it doesn't always have to come to me. That conversation that takes place when, oh, that's the way I did it too. Or, I didn't understand that. Could you say that one more time? We want that interaction to go between the kids as well. And I heard self-correction earlier today, and I don't know if it was in, self-correction just happens in number talks. As kids write their answers up on the board, and as kids listen to the other kids share, all of a sudden they're like, I put one too many in, or I forgot to take that 2 off. And so all of a sudden they're saying, I changed my mind. Can I fix my answer? What was it? So there's so much more power in being able to correct your own thinking than to always be right. I'm going to always learn more when I'm paying attention to what I didn't get right the first time. What was it that I missed? So that self-correction, that's so powerful. We're going to do a little experiment here. All right, you're going to see a word, and I want you to visualize the word. Does everybody have a picture in your head? Okay, did it look something like that? Hope so. How about this one? Something like that? Okay, might have been black, might have been brown, maybe even a polar bear, but pretty much has that big old nose, and we would run if we saw it, right? How about this one? Show me what you see. I see a lot of people doing this, okay? Yes. Did anybody see something like that? Nope. Tried to. Or like that. So what I want to talk about here is in reading, we understand that symbols are symbols and the concept is behind the symbols. And so when I see the word pumpkin, I don't want a kid visualizing P-U-M-P-K-I unless we're doing a spelling test. I want them to see the actual concept of pumpkin. And in math, we've always been fine with when I say 7, you see 7, the numeral 7. What is that numeral? It's a representation. So there's math, and I heard you say this morning, doing the math. We have to do the math. The kids have to do the math. They have to touch it, move it. The symbols describe the math that they're doing. Way back when, I don't know how many years ago, somebody decided that that's what a 7 looks like. They could have done this, and we'd all be writing this. It's just a symbol. There's no math in the symbol. It describes the math that the kids are doing. And if we move too fast without those concrete ideas, then they're missing the math. They're just trying to do math with the symbols, and they never did the math. So that being said, when we think about number talks, who's holding the problems? The teacher is. I'm holding the problems, whether I'm holding a model or a number sentence or whatever it is, I'm holding the math. So before the number talks, the kids need to be doing the math at their tables. They need to be pulling out those cubes, counting those collections. They need to be putting numbers together, separating quantities, comparing quantities. They need to be doing that with their own hands at their tables. So number talks is a step after. So once they've been working with those concepts, now my number talk can include the concepts that they've been working on in your math time. And so that being said, sometimes there's a misconception that your number talk has to match what your math lesson is. And if that's the case, then they haven't had that concrete experience yet. So they need to have those concrete experiences. That's the stage 1. And then number talks is kind of stage 2. We're taking those materials out of their hands. We might still be using materials, but I'm holding them. They don't get to manipulate them. So number talks is always going to be a step behind what we are doing in our math time. Of course, we do counting for a really, really, really long time. So at some point, it is going to match what we're doing, but the introduction of it won't. So what kind of tools and models help students develop computational fluency? I'm going to show some pictures of some what we refer to as meaningful flashcards, as opposed to the flashcards that I used when I was a kid that said 2 + 4. Toothpick cards. If you make toothpick cards in your class, it's kind of fun to have the kids actually organize them and make them, if you trust them with the toothpicks. If you do that, they need to be flat toothpicks because the round ones roll and they don't really glue down. And this is probably not the best picture of a toothpick card because I usually like to use black construction paper so that the toothpicks really stand out as opposed to the white. So thumbs up when you know how many toothpicks are on my card. Just whisper to your neighbor. How'd you know? A square and a square is what? 4 and 4. And one more? 9. So what I used to try to do when I first started teaching, practicing those numbers, all of a sudden I pulled out these kind of cards and my kids were seeing it. And it was amazing to me. I remember trying to teach them how to do the magic 10. So if it was 9, then you had to change the team number to 1 less than the. They looked at me and like, yeah, I got it. And then all of a sudden I discovered 10 frame cards. It's like, oh, that was easy. So the models give them access to the math. Another example, dot cards. I know you've all seen those in lots of different programs. The one thing you'll notice about this dot card is all the dots are one color. As soon as I put color up there, there's going to be one way to solve the problem. So if I had, say, 3 red and 3 blue, all of a sudden the kids are going to go directly to red and blue. By having them all one color, they might see them different ways. Somebody might see that 4 in the middle and the 2 on the outside. Somebody might split it down the middle and see the 3 and 3. So the other thing that you'll notice about them is they're fairly evenly spaced. As soon as I put some dots over here and some dots over here, what have I done? One way to see it. And Number Talks is about the conversation. It's about you sharing your way, and making sense of it, making connections. If you saw 3 and 3, how is that related to my 4 and 2? Oh, you just moved one of my 4 over with your other 2, with the other 2. Okay. So same color, fairly evenly spaced. Number shape cards. They're just squares in different arrangements. 10-frame cards. We use those a lot, and that is the beginning of helping build that structure of the number system. If I can make a 10, we talked about that earlier. If I can make a 10, I can make 100, I can make 1,000. Color tiles, just have a parent cut up a whole bunch of 1-inch squares. And then it's a great station for the kids too. They're building those designs. I want to see as many pictures of 4 as I can. It's amazing all the different ways they'll come up with. Pattern block arrangements. These are just some different ways to show. I know we get stuck sometimes with dot cards, and that's where it ends. The other thing that I want to mention is that in your number talk, I don't have to have a dot card day and a toothpick card day and a color tile card day. I can mix them, and it's when they start noticing, oh, wait, we just saw 3 and 3, and now I'm looking at 3 and 3 again with number shapes, but then there's 2 more. So don't be afraid to mix the media. Okay, when I'm moving up to bigger numbers, unifix cube towers, what do you notice about that? What's missing? 2. That same 2 again. So back to that structure of the number system. I can make a 10 with 2. I can make the next 10 with 2. I can make 100 with 2. Our number system helps, that idea that math makes sense, that starts out when they come to us in the beginning, that's what helps them notice those patterns in our number system. Okay, hundreds grids. For my kids who looked at that problem, 98 plus 46, what if I had that 100 grid sitting up there for the kids who didn't notice? Maybe I'd have another 100 grid that had 46 on it. Can they picture moving those 2 over? So I'm giving them access to the math using models, representations. Just doing the numbers isn't going to help them with the math. And beyond. I don't know why that makes me think of Buzz Lightyear. All right, so these are essentially what we're moving through, no matter what size the numbers. We're looking at counting, number relationships, number composition and decomposition, place value, and then bigger place value. Another thing that I want to mention is just having bigger numbers does not mean they're thinking at a higher level. Okay, so even if I think about my kindergartners counting a pile of cubes, even if they don't have cubes, sometimes we practice rotely. Let's practice counting to 100, and we do it every day. 1, 2, 3, 4, 5. That's not the math. The math is, can you count the objects, right? But counting bigger and bigger numbers is not higher level math. If I have bigger numbers, then all they can do is count. If I bring the numbers down a little bit, maybe they notice which one is greater, which one is less. If I bring them down even a little bit smaller, they can see the parts of the numbers. So big numbers doesn't necessarily mean big math, depending on the age of the kids. Oops, is it gonna play without me? So, this is Becky. She's a first grader. She's a first grader in a multi-age classroom. First, second, and third grade, if you can imagine. I taught multi-age just first and second, and it was the hardest job I ever did. So I can't even imagine 3 grade levels. They had a lot of kids, but they had 2 teachers. So the next couple of kids we're going to see solving this exact same problem. So it goes pretty fast, but try to take note of how she solved the problem, and then we'll talk about it. Whoops.
I knew that 20 plus 10 equaled 30, and 4 plus 8 equals 12, and that made it 42.
All right, what math does Becky show that she can work with? Anybody? Four and 8. Okay. Is that okay? Yeah. Commutative property. Yeah. Anybody else? I heard somebody start over here. Regrouping. Traditionally, way we think of regrouping? No. And we use that word regrouping, and a lot of people think that only means to carry the 1 or break up the 10. Regrouping just means that we're rearranging the quantity. Okay? She had a... She knew those groups of 10.
I think she had a strong understanding, at least, of the tens and ones in place value, and that it was okay to decompose those into tens and ones.
Into tens and ones. Okay.
And the 14 into tens and ones, and so she added not the traditional way, right? She added left to right. So she added her tens first, added her ones, and then combined those two.
How confident do you feel about what's coming next for her in math? Is she going to be able to handle it pretty well? The fact that she starts with the tens, being from Las Vegas, I always like to talk about money. So if I were to throw a pile of money on your table, dollars, quarters, nickels, dimes, pennies, where would you start counting? The dollars, and then the quarters, and then all the way to the pennies. So how would you handle it if I said you have to start with the pennies? Don't want to start that task, do we? So our brains naturally group the big chunks. And so allowing the kids to come to the table with the strategies and the math that they know, this is kind of what they naturally do, because the bigger chunks are easier to put together, just like we did with the money. Okay, I forgot. So let's take a look at Brian. He's solving the same problem. Oh, yeah. Okay, I'll play it twice again because it goes so fast.
20 plus 10 equaled 30, and if I took 2 off the 4 and put onto the 8, that equaled 10, and that equaled 40, and I had 2 left, and that equaled 42.
Now let me play it one more time. So I want you to also think about what's the same about his explanation that as Becky's, and maybe what's different. Not maybe. Same and different.
20 plus 10 equaled 30, and if I took 2 off the 4 and put onto the 8, that equaled 10, and that equaled 40, and I had 2 left, and that equaled 42.
Okay. Talk with your neighbor about how he solved it, what's the same and what's different about Becky's strategy. All right, who would like to share some insight about Brian? What's the same, what's different? His strategy and Becky's? She's running. Oh.
So the little girl she had the automaticity. She knew that 8 plus 4 was 12. She just knew that.
Okay.
And he had a strategy to make 10 first.
So that whole idea comes back again, that making a 10. And she may have already done that lots enough to know. And I think about how I know my teen facts. And I think I know all of them either by making a 10 or a double and a double plus 1. But I know it so fast I don't have to say it anymore.
Right.
Yeah. Anybody else? So the idea that we're going to make another 10 because I have these 3 groups already, and then I can make another one to add to it, okay, and then have the leftover ones. Thinking back, and I know we saw it just for a quick minute, to the tools that we talked about, are there any of those tools that would give access to my kids in the class who maybe couldn't think about that symbolically? 10 frame, and maybe I need to have more than one 10 frame, okay? The base 10 blocks, with our little kids, what do we want to use instead of the ones that are pre-grouped? Unifix cubes where they're making their own 10s, okay? So maybe I have 28 and I have 14 and they can picture taking 2 off and making that other 10. So models give access to the kids who might not be seeing the numbers, and the kids who don't need them, they'll just be using the numbers, okay? The next one is Troy. He's in that same class, same problem. He's a first grader. Oh, sorry. The other thing, I forget I think it was somebody over here who said, the math happens so fast in your head, but it takes a little longer to explain. If you saw the beginning of the video where Brian, the problem is given and Brian's thumb goes up like this. So it took him a minute or two to explain it, probably not even a minute, but the thinking happens super fast. So you have to keep that in mind with, let's see, I think I have to back out every time, sorry. He's even got bedhead. Oh.
30 plus 24 equals 54 plus...
Something happened. Okay. We're going to look at him first as a first grader. Here he is.
I had 28 and I counted 14 more.
And how'd you do that?
I counted on my fingers.
All right, so you counted on from the
and I had 42.
You got to 42. Okay.
Strategy. Think about his demeanor, his disposition, and why it is that he seems just as confident sharing, I counted on my fingers, as his classmates did, sharing their making 10s.
He's probably been supported in his classrooms over the days, in doing it his own way.
So it had to have that safe environment where there's no judgment on whose is a better strategy, okay? Yes. And that's a good thing. I'm gonna stop. Sorry. Okay, before we finish up, because we're running out of time, I want to show Troy as a second grader, because the question is Troy always going to be a counter honor, or if he has the right experiences and the right opportunities, is that going to grow and become more sophisticated? Yes. Okay, which you already got a glimpse.
$30 plus 24 equals 54 plus 6 would be is 60 plus 1 more equals 61.
And where'd you get the 6?
I broke the 7 into 6 and 1.
All right, thank you.
Okay, I'm going to play him one more time. Remember last time he said 28, 29, 30, 31, 32.
30 plus 24 equals 54, plus 6 would be is 60, plus 1 more equals 61.
And where'd you get the 6?
I broke the 7 into 6 and 1.
All right, thank you.
Who's talking? I heard somebody.
So I would just say it's very obvious he's had a lot of experiences with math and taking numbers apart and putting numbers back together again.
Maybe collections. So what I want to tell you about those kids is they're at a school where previously they hadn't been doing a lot of, I'm going to say it, meaningful math. And they decided to bring out the materials and have kids work with materials, probably doing collections. They did number talks every day, 5 to 15 minutes every day in every classroom. And it shows. Giving the kids opportunity to explain their thinking, to come to the table with their math and not think about what my teacher wants me to do, but I get to solve it the way that makes sense to me today. And maybe in a year from now, my strategies are going to be different. They're going to be more sophisticated, but she's going to honor me all along the way. So that's one of the goals of number talks. We're running a little bit out of time, but do we have till 50? All right, so our rule in helping these kids move forward is that safe environment so that they can learn at their pace. Our job is to select problems that are meaningful to the kids. That means I can't follow a script. That means I can't use predetermined sets of problems for my number talks. I have to think about what my kids did yesterday and choose problems based on what's going to help them move forward and not that I pulled out of a book. It has to be related to what the kids in my class need. Can't follow a script. We provide wait time. That thumb, it's built in. Values everyone's thinking. Every kid's strategy is valued just as much as another, even if it's not as sophisticated. Records, clarifies, and restates. I have seen sometimes where people have had kids come up and record, and during number talks, for one thing, it takes so much time, and our number talk is so short, it's not really efficient to have the kids come up. And then the other issue comes when sometimes they write things mathematically incorrect. So number talks is a time for us to scribe and not our kids. There are other times for them to write down, but not during number talks. Asking questions to help them clarify. Here's some questions that we might use. How'd you figure that out? Who did it another way? Now, if you work with little kids, if you ask for a different way, you're going to get it, even if they didn't do it that way. If you showed them a dot card that has 5 dots on it, somebody's going to say, well, I thought about 10, and I added 2, and then I took 7 away, and then I counted 3 more. You're like, no, you didn't. So there's this fine line about asking for another way and knowing when to quit, because then you're just going to keep getting other ways. I've started trying to, and I don't do it all the time, is who else wants to share? Because then you're opening it. If you solved it and somebody else already said that, I still can say it again, because that's really what they want. They just want to share. So they're making it up. Kindergartners and first graders are the worst. The best. The best at trying to be fancy. Okay. And we talked about this. We're just paying attention, to all of those ideas when the kids are sharing their thinking. Our goal is learning how numbers are composed of smaller numbers, seeing those parts within the bigger parts. That's what gets them started on addition and subtraction. If everything is 1 by 1 by 1 by 1, then addition and subtraction is going to be counting this, and counting it all. Okay? What we know about one number helps us figure out the others. And numbers can be taken apart in multiple ways. That regrouping that you were talking about, not in the traditional sense, but that we can move numbers around, be flexible with them, and use them how we need them to be used in a particular problem. I love this quote. And I think it goes back to what Dr. Frank said earlier. It isn't about getting to mastery, because we're never there. It's just the beginning, and there's always more. So remember, keep it short. Try to do it daily. I also say give yourself, a chance to learn. Like, don't be hard on yourself. Not every number talk is going to be perfect. I've been doing them forever, and sometimes I go, oh my gosh, it's terrible. And sometimes you're like, oh my gosh, that worked out so well. And if you walk away from your number talk saying, oh, I wish I would have, now you've just planned tomorrow's number talk. So give yourself a chance to grow and learn, and don't be hard on yourself. If you're giving the kids a chance to think and a chance to share, then they're doing it. Wherever the kids start counting, let me see if I explain this. If they're always counting, then I need to bring the numbers smaller. Okay? I need to find the place where they can see small groups and count on. So I'm always thinking about what I can do, what's the model I can use, what's the problem I bring out that's going to help them move from counting everything to counting on or seeing small groups. If it's too difficult, make the numbers smaller. Thank you.